Thank you, Sam, for hosting me. And thank you, Sivo and Security Compass for kindly sponsoring this event. So I see a lot of new faces. So this is my second OWASP talk this year. Can I quickly ask, by show of hands, how many people have heard of dep-scan? Okay. Software composition analysis in general. This is awesome. This is actually a perfect mix. So I can actually balance both introducing software composition analysis, OWASP, and also about dep-scan. I hope this one is all right. So like Sam said, we are relatively new to OWASP. So dep-scan used to be my hobby project. And I was consulting for my company AppThreat and trying to make money from various open source projects. We are an incubator project at OWASP. And currently we have 4 leaders on dep-scan projects. So we have Caroline, we have Aryan, Tim, and myself. Caroline and Aryan did all the work for dep-scan v6, but I'm going to present and take all the credit today, okay? And Tim is wonderful. He's been helping us with a lot of .NET related stuff. As an OWASP project, we are open to newcomers. So Aryan, for example, is a student who joined us only 6 months ago and is one of the leaders. So we will give you all the training, all the tools, all the things to help you get started. We also have funding, so we get EU funding. For example, one of the first OWASP project to get EU funding. We also have a bunch of sponsors and so on. So it's a very short agenda. I think, like I said, I've given a talk earlier about dep-scan version 6 at Lisbon. So what I would highly suggest you guys to do is go check that talk out first later today, and then rewatch this, because at the Lisbon talk I introduced our vision of what we are planning to do for the end of the year, but today you're going to see a live demo. And even if you had come to my Lisbon talk, today is going to be new, something interesting. And I don't do quite often. And dep-scan as a project is 5 years old. And that's my very first announcement on Reddit saying, hey, I'm working on dep-scan. It's a free open source project. You guys check it out. So it's a 5-year-old project. But like I said, it's at OWASP for a year now. So what I'm going to do is actually start with the demo. And then we can go through various things, and I can keep it very technical if you guys are okay, or we can, tone it down. We can go broader and so on. Show of hands if anybody really wants like a marketing speak full of buzzwords. Okay. Okay, so I'm going to run dep-scan. Okay, if you flick or sneeze, you will miss it. Okay, so this is Juice Shop. Okay, 17.1.1, the latest. Okay, I'm running dep-scan. Did you guys miss? Shall we run it again? Okay, so to show that I'm actually not faking it, so I'm going to run the tree command. This is full Juice Shop. Any Juice Shop fans here? Cool. So yeah, I'm not faking it. Full source code of Juice Shop. Okay, and I'm running dep-scan again. This is the full shebang, right? Dep-scan, profile research, explain. So do all the analysis, reachability analysis, this and that, and then explain beyond doubt all your findings. So I'm going to run it again. Dep-scan, logo, performing scan. So dep-scan with reachability analysis is faster than OSV scanner, which doesn't even have reachability analysis. Okay, let's digest that again. Dep-scan with full reachability analysis is faster than Google's OSV scanner, okay, which doesn't even have reachability analysis, okay. Goes to show the amount of effort my colleagues Aryan and Caroline have put in the last 1 year, okay. So let's look at what dep-scan is trying to say here. So what I'm going to do is I'm just going to do less command and slowly walk you through what's going on, okay. So let's run it again. Is it okay now? Okay. Software composition analysis is one of those tool chain that's highly prone to false positives, because fundamentally you are operating with very limited context, right? Like you can run a SCA tool with any repository, any microservice application, anything out there, right? Then you are expecting the tool to perform magic, right? Like tell me all the risks and vulnerabilities in my software composition, in my third-party libraries, in my open source dependencies, and so on. So which means there is a tendency to over-report vulnerabilities, over-report risks, like hundreds of them. Like Juice Shop, for example, is a known vulnerable application, right? So there'll be obviously hundreds of vulnerabilities. And same, if you take any real world applications, enterprise applications, so most tools will come up with lots and lots of issues. And then like we heard from Trevor, it leads to frustration. There's just too many tickets, right? Like who is going to fix them all, you know? And then people lose context. People lose, in fact, trust in the security process if they are faced with too many vulnerabilities and so on. But the tricky bit is not all of these vulnerabilities are risky, right? There could be numerous potholes on the road, right? But you're not worried about all the potholes, right? You can still drive the car. We are only interested in highly specific, you know, potentially exploitable vulnerabilities. Very small category, isn't it? And that's usually only one hundredth of them, right? But the issue is how do we know which of those vulnerabilities are exploitable, right? That is the most difficult questions, and there are a lot of techniques, a lot of snake oil techniques, to be honest. But with dep-scan, what we are trying to do is try to solve it the hard way, but by proving essentially all the important bits. For example, what we are seeing here is so there is a vulnerability, there is a dependency tree, and dep-scan is then trying to give you more insights about it. It says, hey, this package is used in 16 locations, right? And then if you keep scrolling, it says, oh, this express JWT, it's not only used in 2 locations, but it is also reachable. So the definition of reachable as per dep-scan is an adversary or a threat actor can reach externally by injecting a payload and so on. So true reachability analysis as explainable by a threat actor operating externally to the system and so on. dep-scan has a lot of parameters. So what you're seeing here is like a verbose mode. So it's trying to basically explain every single analysis beyond doubt, because we don't want the issue of false positives and so on. And here is the kicker. It still says no package requires immediate attention, because it knows a lot of context about what this application does and so on. So it still says there are no vulnerabilities that needs to be remediated. And I'll show a lot of examples. And then there are more things we can have explainable reachable flows, and these are data flow analysis. So this is not grepping, or this is not a simple call graph or something. This is true data flow analysis, where every line, every flow will be explained, annotated with the exact packages that participate in the flow, and then yeah, it plots all these things, and it often comes up with a useful idea. So this is Juice Shop. Any questions so far here, or should I explain? Okay, I'll take one question. Yeah. Yeah.
Prabhu, would you be able to repeat the question?
Okay.
Okay, I've got two questions. I mean, first thing is, I mean, this seems like a lot of that. Is it available commercially?
It is free open source, MIT licensed. OS project.
Second question was around vulnerability and exploitability. Do you identify what exploits are actually out there exploiting? Do you have any indications of that, as it were, depth attack on the dark web with those vulnerabilities?
Okay, it's a good question. I think I'll try to explain. I have a slide on it. I'll try to explain what's going on and so on. The question was about exploitability, whether we have data from the dark web and so on. So this juice shop. So far I showed reachability analysis with version 6. It's now very fast. Okay. Even though it took seconds, we generally ask for 2 to 5 minutes. The idea is that we will do more analysis that will save you several days or even weeks. So the idea is not to produce a very quick analysis within seconds. Okay, that could be for the the mainstream CI/CD based invocations and so on. But if users give the tool enough time, which is around 2 to 5 minutes, we can do much more analysis and reduce false positives further to single digit for a large number of applications and so on. So let me show another cool thing. So when dep-scan did this analysis, it can also do what is called as open API generation. So this is endpoint detection. Okay, so Juice Shop unfortunately do not publish any Swagger open API specification at all, right? If you see the code base of Juice Shop, it's an Express app. It has a bunch of middlewares and creates routes on the fly. They create a lot of dynamic routes on the fly. So which means it is very essential to understand the exact endpoints an attacker could likely use to try and exploit an application. And dep-scan is probably the only tool which can recover the endpoint information by statically analyzing the code. Okay, and it can generate a precise open API specification for real-world applications entirely using static analysis. So this is dep-scan generated open API specification for Juice Shop. And as you can see, it can even capture the parameters behind the endpoints, their types, and so on. So it can even capture file line number information. So while building this feature, this was funded by Forward Security and Smithy. I think Richard from Smithy is here, something. No, so we received some sponsorship while building this feature. And we collaborated heavily with Simon from Zap team, right, who now works for Checkmarks. So we used dep-scan to automatically generate an open API specification. And then we injected this open API to the Zap tool to test all the endpoints and so on. We found that this technology improved the performance of Zap by over 90%, because without this information, any DAS tool have to do spidering and other things to learn, and that's very error prone and too much time, right? Like somebody has to run the Juice Shop application and click all the buttons and put all the key payloads. This is not only the endpoints, it is also the type. So a DAS tool can generate precise payload. And very soon we will add a lot of other information. So we will also add any known CVs and so on. So maybe it will become fully compatible with Nuclei, okay, Project Nuclei. But we have some exciting things. And this particular feature, we call it as endpoint reachability. So dep-scan is the first SCA tool in the market, all SCA tools, open source, commercial, to implement endpoint reachability, which is precisely telling you the endpoints a threat actor could use to reach an application, right? Again, very, very precise. While I'm showing it for JavaScript, it works for Java and a number of other languages. So my next example is a Python AI application. Okay, so I'm going to show the dep-scan output for this particular AI application. And you can see that it says indirect dependency. And then for this particular CV, it says reachable. And then if you scroll down, it plots the full data flow. And this is Python. And what I want to show here is tags ML. So this is called semantic tagging, and it's a feature we added recently in CDXGen version 11. Okay, I am trying to go faster. So because we have been working in on this projects for over a year now, like 4 of us, we at least need a week to explain all the projects. Maybe what I can think about is like a training session in the next OWASP. Show of hands, how many people will be interested in a 3-day training course about all the all the things we've added with SCA and SBOM. Okay. It'll be very in depth, very detailed, so we'll think about it. Right. When CDXGen generates any xBOM, right? xBOM, not a software bill of materials, but CDXGen can generate a lot of kinds of inventory. It can also try to tag the information. What is this package doing, right? And we have a range of heuristics. We have a hard-coded list of all top ML frameworks, web frameworks, HTTP frameworks. We can also parse the description text. We can also parse the tags from the registry and so on. So we can automatically tag. And dep-scan now makes heavy use of these automated tags to compute reachable flows. And it does a lot of prediction. So your question about do we have any exploit data? So we have vulnerability data. Okay, so we have a project called VDB6 where we collect vulnerability data from a lot of sources. We normalize them. We enhance them by identifying affected modules, affected symbols, a lot of things. Then the rest is prediction. So we predict all the reachable flows. And if you take all data flows, right? A small subset will be reachable data flows for an attacker, and then a small subset will be reachable vulnerable data flows, and then a small subset of that will be reachable vulnerable exploitable flows. We are now trying to use prediction to predict how many of these reachable vulnerable flows are potentially exploitable. Okay, so there is a small percentage of false positives here. But it is very low. If you quickly think about what the commercial companies are doing, it's very basic, right? So they hire a bunch of AppSec people whose sole job is to go through the CV description, come up with module names, class names. Mark Offrey did a company called SourceClear 10 years ago and sold it to Veracode. And almost all security companies are doing the same thing even till now, right? Total lack of innovation. Whereas with dep-scan, we're trying to automate this process. When you put humans into the picture, a given human may not understand all the languages, all the intricacies of various frameworks and so on. So they will underreport the affected modules, affected symbols. Whereas when we use a tool, it will over-report because a tool will see every single symbol, every single class. So we figured out a way to mimic the human analysis while doing automated analysis. So dep-scan can identify a number of mitigation in place, and it can automatically suppress those flows that have mitigation and so on. So maybe if we come across an example, I'll show. It will usually show those mitigated flows in green, and then it'll say check whether there is any mitigation in place, and so on. So this is dep-scan for a Python AI application, and incidentally, many of these flows that dep-scan is plotting are actually prompt injection attacks. Just that it doesn't know that it is called prompt injection, right? It's saying there is a flow, whereas there is a framework provided input going to a ML library, but it doesn't know that humans call it as prompt injection. So we are working on an explainability project to basically teach dep-scan how to classify various flows, give it a human-specific metadata. So when version 6 gets released, soonish, okay, it will have very high quality explanation text for various data flows. Any questions? I'll take one question around this.
Yeah, so I have a question. But the main one is, so you're doing things for analysis. You're following the things of the variable.
Correct. Correct.
You're tracking that sum. Do you have do you start with the vulnerabilities and what is in the vulnerabilities? Then you walk backwards from it. So you take a vulnerability that's in the middle of a and you go and you say, right, this goes, this type of input, that reaches that way, then you have a problem. You have that there?
So we compute all the reachable flows. So let me repeat for the sake of live audience. The question was, do we start with vulnerable taints and then propagate backwards? So reverse reachability. So so we compute all possible reachable flows and then try to predict reachable vulnerable flows. And then given CVE information, we then try to classify whether any of those vulnerable flows have a known CVE associated with it and so on. So we do the hard way. So which means we are also proactive. For example, we can plot potentially reachable vulnerable flows even if there are no CVEs. So you will have a very good head start when using dep-scan. The example I showed is predicting struts vulnerability for Experian. So we can run dep-scan against many real world vulnerable applications, and dep-scan would plot potentially reachable vulnerable flows, just that you don't associate a tag called CVE with it. But to a skilled person, they can see it is plotting the correct one. So let me show the next example, and then I'll take one more question. And yeah, obviously we can have more questions at the end. So this is the second example is about Python and AI ML applications. So dep-scan is probably the best SCA tool for Python application. We cover till 3.13 actually. So the next example is .NET. Again, dep-scan is the best tool for .NET. We support from .NET Framework 4.7, then .NET Core 2.1, 3.1, 6, 7, 8, 9. Okay, broad. So Tim, who works for us, is unbelievable, right? So what I'm showing here is how Microsoft will present the vulnerabilities when you build a project. Okay, so this is Microsoft. I don't know how many trillions they have. This is the kind of interface they have to show vulnerabilities. And what dep-scan can do is render a nice tree, can also show usage analysis where exactly the packages are used. And what we can also do is what is called as lifecycle analysis. So which is we first generate an SBOM from source. So this is called pre-build SBOM or build SBOM, right? In CycloneDX format. And then we build the application using .NET or MS Build. And then we generate a post-build SBOM from the binary. So we have a project called Blint, which is an excellent binary SBOM generator. So we will parse the binary and we will recover an SBOM of all the libraries that got bundled into the binary. And then by then mapping how many of the input libraries from the source eventually got bundled, embedded into the binary. We can do what is called as lifecycle analysis. And this will again can be used to cut down false positives a lot, because not every dependency from your source, your build, will eventually get deployed. And so this is an example for dep-scan doing lifecycle analysis for .NET. We will support at launch lifecycle analysis for .NET, Go, and Rust. Then we will add C, C++ support sometime next year. Okay, now let me start going through the slides, and then we can obviously take turns and have some, make it interactive and so on. So what is dep-scan version 6? So we've built an ecosystem of next generation tools, and most of these tools are available as free open source under OWASP. In fact, all of these are free and open source, just that Atom alone is still an app thread project. Let me think about donating it at some point, but Blend, CDXGen, and all the other things are under part of OWASP. And Atom is an intermediate representation and a reachability analysis tool. So if you guys are familiar with SEMgrep, it uses a representation called TreeSitter. Then CodeQL, SML, they have their own representation. So we have our own representation, which is highly optimized for supply chain analysis use cases. So with Atom, our intention is not SAST or looking for 0 days and so on, but reachability analysis and exploit prediction. It's a much simpler representation. We have front-end support for a bunch of languages. And then we have Blend, which is a binary linter and an xBOM generator for binaries. Has anyone heard of Blend before? Okay, one person. I will show a page about Blend. And CDXGen version 11. It is called CycloneDX generator CDXGen. It's a polyglot xBOM generator. So with CDXGen, we can generate software bill of materials, operations bill of materials, cryptography bill of materials, a range of bill of materials. And dep-scan can actually use all of those information to precisely categorize CVEs. So version 11 came out only 2 weeks ago. Version 11 was built specifically for dep-scan version 6. Anybody saw the announcement for CDXGen? Or does anybody use, say, OWASP dependency track? Okay, one person. Okay. OWASP dependency track. What SBOM tool do you use to integrate with dependency track? CycloneDX Maven plugin, yeah? Okay, cool. Awesome. So CDXGen is a polyglot version of it. It supports many more languages. You should try it out, and then you can give me let me know your comments. It should beat the Maven plugin in accuracy and speed. Okay. We support Gradle also. Yeah, broadest range. And with version 11, we actually launched a tiny version of it as a ChatGPT app. So yes, there are mixed sentiments about using AI and so on. But the way we look at it is we have a lot of projects that are high quality data generator tools. So when you have high quality data, then you will get very good results with many models. Yes. Okay, so CycloneDX generator CDXGen is available currently on the ChatGPT store. It is free as always. The idea is that if you have any xBOM generated by CDXGen, you can use this bot like a Q&A bot or a reasoning bot. So you can ask questions about the xBOM. So the example here is I uploaded the juice shop xBOM, and then I asked, can you list 10 build and develop packages that can be filtered? And you will get very high quality response because you are setting the context and you're making this agents only use the information uploaded and so on. And we have a lot of we have some ambition to expand this capability, come up with dep-scan version of all these bots and so on. So I'll talk about that in the roadmap plan. So like I said, we have a vulnerability database project, VDB6, and this is the first vulnerability database that is powered by package URL Perl and verse. Verse is version range specification from the Perl people. It's very precise, very accurate. So I have the database with me. Okay, so this is how it will look like. It's a SQLite database. Let me see if I can zoom this further. If not, you can find all these on the link on the dep-scan pages. So you can see that it has the CVE ID, the package type, and verse and Perl, and we have the index database, and we have the larger database, and so on. So by adopting these toolings, you're not logged into any specific closed source standard, right? So the tools will create consistent CycloneDX specification. CycloneDX specification is open source. The tools that generate data are open source. The database is also open source, and so on. So there is absolutely no lock-in when you use any of these OS projects, any of these projects. So I have a lot of users who use these tooling with OWASP dependency track, and it's a complementary tool. So we are not replacing, we are not competing with tools. Rather we are focusing on specific analysis, specific things that we can improve upon. So if you look at the broader space in the supply chain security, supply chain assurance space. So I showed a screenshot of CDXGen bot, and we have a lot of users using dependency track with our tools. We also have commercial security platforms. So I've mentioned a few of these who are already using these open source tools. Okay, so and then I put a bunch of these guys. I've not put the logo because they don't directly acknowledge the use of those our projects, but in the documentation they've kind of said, hey, we are using these projects and so on. So when I shared the slides, you will know these companies. They are very rich companies, and I'm not going to ask you guys to guess how much money they have donated to OWASP and so on, but I'm sure you will have the answer. We are absolutely fine. The point is, because we are building high quality tools to solve specific problems, we are absolutely okay with everybody benefiting from our work, right? That is the mission behind OWASP. Make the whole world safer, not get rich quick, by starting a security company and so on. Okay. With version 6, yeah, like I said, we are doing what is called as full stack composition analysis. So even though we are used to software composition analysis, if you go check out my Lisbon talk, I try to explain the problems, the limitations of software composition analysis. So why we need to think about full stack composition analysis. And dep-scan V6 is the first tool that can make use of a lot of context, right? Like if you have software bill of materials, if you have the endpoints information, if you have the cryptography information, if you have the operations, like the operating system used, the orchestration and everything, dep-scan will use all of those information. It's like a middle out analysis. So it starts from the composition, and then it can either go left, plot the reachability on the code, or it can go right, look at the infrastructure, the layers of defenses, and so on. And it can use all of this information to triage and reduce false positives. Okay. The second thing we are adding in version 6 is semantic reachability. So I showed an example for web, which is HTTP endpoints. We saw juice shop and so on. Okay, but what about mobile? What about other applications, right? So if I can quickly show an example. So I have Signal. Okay, so I used dep-scan to scan Signal Android app. Okay, real app. It's not a it's not a sample vulnerable app or anything anymore. And most SCA tools, including commercial tools, would not actually work, right? Because the chances of something as complex as Signal using a commercial platform is very low. So most product owners will not bother building scanning capabilities. OWASP, we cover a broad range. So with Signal, when you scan the source code, right, dep-scan is reporting a lot of vulnerabilities with known exploits, right? Like this Jackson data bind. And if you keep scrolling, it even says that there are 4 vulnerabilities with known exploits that needs to be immediately fixed. Okay, so this is dep-scan operating with just the source SBOM information, right? It is doing a lot of triaging, but still it says 4 out of 87 vulnerabilities needs fixing. Okay, limited context. But once we had the semantic information of the app, right? What is this app? How is it meant to be executed? So, for example, if I show the post-build SBOM, okay, generated by okay, so this is a post-built SBOM generated by Blend. And what you will see that we are capturing all the semantic information about the mobile application, right? So we know that these are the permissions used by the application. Okay, so we know that Signal application can accept images, can create files in a specific directory, can access your SMS, can do push notifications. And then we then go and check whether that Jackson data bind vulnerability that was reported can be reached using the entry points the Signal app supports. And so if you look at the post build, unfortunately, because the work is in still progress, it's just empty. Okay, so ideally, you would expect the tool to say, hey, I've done all the wonderful analysis. Your Android application is completely safe, right? So that text is missing, but you get the idea what is coming in version 6. So this feature, we call it as semantic reachability, where the tool will exactly know the semantic context of what it is scanning. That's why the analysis are very accurate. And I would suggest go rewatch this recording and ask any commercial company if they have even heard of the term semantic reachability. Okay, if they have not heard of the term, please ask them to join our team. We will even teach them for free. We will help them implement all these features. So I'll take a question now.
I don't want to be the bad guy. So when vulnerabilities identified as late, what is the proactive approach that you are using on the
when a vulnerability is identified in
CVE? That means that it's late.
So what recommendation would the tool offer? Correct the remedy. Okay, the proactive approach has implemented currently is even before the CVE is filed, it will suggest packages that can be monitored. So it'll say, here are the frameworks that are more likely to face a lot of reachable hits. So set up any alerts and notifications for any new CVEs. And then once there is a CVE, how do we remediate it? Yes, that is a good question. So ideally, we have to make the CVEs non-reachable. Okay, most people will say patch, just bump up the version. Okay, that's only 10% of the work, right? So the proper thing is to find out how do we make it non-reachable. It is quite possible that we don't even need those libraries or packages. Okay, for some packages, for container images, dep-scan will even say these packages can be uninstalled safely. Okay, I don't have an example with me here, but you can feel free to try dep-scan on container images, and it'll say these packages are not required, so therefore can be uninstalled. Okay, so no need to patch anymore. Or yes, there is a CVE. First, make them non-reachable by adding mitigations and validations and so on, and also consider patching. But patching and upgrades may not be always possible. So so there is a leeway around managing known risks and so on. So those are the options dep-scan would offer. Yes, sir.
Those things not reachable. The question is your tool detects is a package pull out with the reachable within the code, and that's when you scan the code base as well.
Correct. Currently, we scan the code base. We make use of information in the xBOM, so we also look for additional layers of defenses in the infrastructure and everything. Okay. Yeah, I mean, yeah, the GitHub links are there. I will share all those links, and then you can take a look at the various projects. Any question on this slide? How are we doing with time, Sam? Few minutes left. Okay. I think we've covered the demo part. So what's coming in 2025? I am actually relocating to Cornwall. So I'm originally from north of London. And these are the new app threat offices getting built in Cornwall. Okay, so for people new to Cornwall, there is a very famous garbage collector in Cornwall called the GCHQ. So yeah, so not up to scale, but my app threat offices will be in a form here. And one of these buildings will have a machine learning lab, and there is a wind farm very close by, and there is a biomass generator. So my lab will be entirely powered by 100% renewable energy. So we will have some machine learning extensions for dep-scan. So this is dep-scan for machine learning, not dep-scan powered by machine learning, right? There is a difference. We want to make the next generation of AI security companies possible with dep-scan data. So we will have a lot of ideas around it next year. We're working on what is called as binary reachability analysis, which is quite cool. There's only one company right now who is doing it, but we feel we can do it in a much better way. We are also looking at dep-scan for Internet of Things, routers, cars. We have a lot of automobile customers using CDXGen, Cyclone DX, and everybody is like, "Hey, how do I scan my connected cars applications?" Right? Like I'm sure we know the situation with Kia and so on. So there is a lot of opportunity. We are looking for sponsors. All these wonderful things. We need a lot of money, so we actually have to pay the market rate to the staff, and I should also take a market rate to produce things that can be then used for free for public good. So we have to speak with money, really. So speak to Sam. I can also share the link to donating to OWASP. Okay. I think good projects, good initiatives must be rewarded, like period, right? Like I would love to ask how much you're currently spending on other tools, but I will ask at the pub later today. But yes, with money we can do amazing things. So this is the GitHub repo. You can go find all the ABCD projects under the OWASP Depscan org. Okay, all of them are available free open source MIT license. You don't even have to tell me that you're using it. There is no telemetry. There's absolutely nothing. And thank you so much for your time. This is dep-scan v6. And it's